we've been working with breast cancer cells. This is a specific lineage that is available to researchers. And when you culture them, they grow very well in the flask. We can get these up to millions per milliliter in just a couple of days. The interesting thing about these cells is you can then treat them a little bit gently, but then put them in liquid nitrogen and freeze them and store them in the freezer or under frozen conditions for months or perhaps even years, and then decide, well, we want to look at them again, bring them back up, and they are alive again. That is, they begin to divide, multiply, and things like that. And so it's a very good strain of cells to work with. Not so good if it happens to be in your body. Well, we've looked at the effects of a variety of different venoms, and this is simply a list of all different venoms on these different cells. This is if we don't treat the cells with anything at all. The number of cells here is very, very high. It's a little bit over 1 million in our particular assay. With these various venoms, what we see is that it knocks them way, way down. Okay? Well, that's a nice initial assay, but unfortunately, venoms are very complicated, and so we don't want to cure the problem by killing the patient. That tends to be frowned upon. We've also been looking at a couple different species and asking the question, is this a concentration-related sort of effect? That is, as we increase the dose, do we have an increased effect? And in some species, we see, yes, that is. And so this is one that we're going to follow up on. This is a snake that if it bites you, it's extremely dangerous. This one's not so good either. It's a Brazilian snake. But what we see here is there is a slight effect depressing the rate of the cancer cell proliferation. But you give it a lot more, 20 times as much, and you don't see a significant effect on that division rate. So what we have then is some preliminary evidence here suggesting that some of these compounds are going to be very, very useful for treating certain types of cancers. And I have a colleague at the University of Southern California who has been working with a compound from copperhead venom that is actually chemically rather similar to that AP11 that we talked about. That compound that he's worked with for 10, 15 years is now in clinical trials for treating breast cancer. And it shows a high degree of promise. And so in these venoms then, we do have these biological activities that are tremendous. And so they are what we can call a pharmacological gold mine. Okay? And there is a good track record from the literature that these venoms contain all sorts of interesting things that we can use. We just need to pull apart the complexity, get the ones that we want, work with those, and then develop those as potential tools. One advantage that we have here at UNC, which is different than a lot of places, we're not a Research One institution, but we do have a nice university-sponsored animal facility. It's just been renovated. This morning I spent time moving our animals back into the facility, so it should be up and running again shortly. We actually do the extractions here. That's rather unusual. Most researchers actually buy the venoms from a chemical supply company. They get a little bottle, comes with a label on it, and they hope that it's been extracted properly. Most of the rear-fang snakes are not available commercially anywhere. And so if you want to work with these, you need to work with the animals themselves. And that becomes difficult for many people. But we, in fact, have been doing that here for a number of years and very successful. What we're hoping, of course, is that as we discover these novel toxins, characterize them biochemically and biologically, then these will begin to lead to rational drug development and drug design. And as I've mentioned, there's good reason to think that that's the case from the literature and also from our preliminary work. Okay? Well, again, in addition to the people that I mentioned at the start, who we are working with right at the moment, many, many students and friends and colleagues have been very, very helpful in all of these efforts. In addition, support from Colorado Bioscience and a number of other agencies have funded our research here and allowed us to take it to where it is today. And I'm very pleased with where things have gone over the last 5 or 10 years. It's actually pretty phenomenal. With that, I could go on forever, of course, but with that, I think I'll let someone else take over, and I'd be glad to entertain any questions that you might have at this point in time. Thanks for your attention. Okay. question? Yeah.
I do have a question.
All right.
When you show the differences in the growth of the cell cancers, how in your mind are you envisioning the delivery of that? Or how does the venom affect non-cancerous cells?
How does the venom affect non-cancerous cells? That's a good question. And that is a little bit more difficult to get at. It's not impossible, but non-immortalized cells don't grow as well as these immortalized cells. They're not quite as bulletproof. But those are essentially the next set. And so it's not surprising that the venoms, the crude venoms, knock out cells. There's all sorts of things in there that should do exactly that. What is interesting is the variation that we see between the different species, because many of the compounds that we expect to be general cell killers are present in the ones that don't. And so sometimes that negative result is actually indicative of something possibly very interesting. So again, we're at a relatively early stage of the research here. We're trying to scan as many different sources as possible, move in and purify away the compounds, and then evaluate those specifically. And as we get compounds that are discrete compounds, single components, then those will in fact be subjected to tests with normal cells. And we've actually earlier this year I gave a presentation with the Front Range Larimer County Bioscience group and made a number of contacts with people at CSU and other Front Range institutions, and the potentials for doing precisely those kind of assays are great. So.